Is it 4-2?
4-2.
Yes.
Okay. So getting into like we talked about yesterday, position, velocity, acceleration, going back and forth between them, understanding a few things involved in it. We'll probably spend today and Monday on this. Let's start off with this. The position function would be S of t, and let's say we're in meters. So the label on the position function, we talked about this yesterday a little bit, would be meters. Velocity is the change in position so it's the derivative of position, it's S prime, and it would be meters per whatever, I don't know what the, so this is in seconds, so it'd be meters per second. Can you see the red there? Is that fine? Acceleration is change in velocity. So it's either S double prime or V prime. Could be either one. And what's the label there? Meters per second squared. Or like you could say per second if you really want to. So one of the things we do down the road is I give you a graph and you got to graph the derivative of it. We're not getting deeply into that yet, but I'm just going to start talking about it because we're going to try to graph if this is my position, what's my velocity, what's my acceleration. So I can use the equations, but I'm going to try to kind of talk through it with them. So this is a position graph. So this person started 2 units because of that 2 to the right of home base. So think about it like your right is positive and left is negative. Or sometimes it goes up and down. Up is positive, down is negative. So this person started 2 units to the right of whatever their home base was. For this part, they're getting further away from their home base, right? So is their velocity positive or negative? Velocity is positive. You're moving in the positive direction because your position is getting bigger. Also, what is the derivative of position? It's velocity. Derivative is slope. What's the slope of this position graph during this part? Is it positive or negative? Positive. So is your velocity positive or negative? Positive. Then we get to here. At that instant, kind of stops for a second. So what's the velocity right at that spot? It doesn't stop for a second. It stops for like a blink of a blink. And so what's the slope of the tangent line right there? 0. What's the derivative right there? 0. And then on the way down, same type of thing. Now we're going like back towards our home base. The slope of this is negative, which means the derivative is negative. And if I wanted to graph the derivative, I could just take the derivative of that. So S of t is negative 4.9 t squared plus 18t plus 2. So V of t is just the derivative of this. So it would be negative 9.8 t plus 18. So one of the things we kind of start with, so this started at 18. 18 divided by 9.8 is like a little less than 2, so I don't want to do this exact, but it's something like that. One of the things we'll get into is there's no like formal definition of this. This happens every year. I'm just going to ask you a question, and somehow magically, even though you've never heard this term before, you're all going to say the same thing. Maybe. I was going to screw up. How many wiggles are in that graph?
1.
Yeah, of course I do.
Oh, it is 1. It is 1.
I would have said 2.
2? 1. There's 2 curves.
Like one there and one there.
There's 1 wiggle. A wiggle is down and back.
Yeah. It's like saying a zigzag.
Yeah. Like Exactly.
Exactly.
What about if I said like how many curves does this have? Do we agree that's two?
Yeah.
Okay. How many curves does this have then? How many curves is that at? Do we agree it's three? So like 1, 2, 3, is that kind of what you're going, right? So this would be like x4. If I take the derivative of that, it would look like that, which is x to the third. If I take the derivative of that, it would look like that, which is x squared. If I take the derivative of that. So what I'm trying to point out to you is that every time you take a derivative, you lose a curve. So like x to the fourth down to x to the third, there's one less curve, right? Here to here, there's one less curve. And then what's less than one curve is like, that's no curves. And then what's less than that is actually like horizontal. I don't know if that really makes sense with the curves thing, but because this was a parabola, it's got one curve, the derivative will have no curves. So it tracks that it would be just a line, because the line has no curves. If I wanted to do the acceleration, I can take the second derivative. So the second derivative of that will be a of t equals negative 9.8. Well, what's that? Yeah, it's a line. It's gravity though, right? Like, isn't that how gravity is? So the acceleration is just a horizontal line here at negative 9.8. This would be, I think I've drawn this like 4 times and erased it. So to me, this kind of continues the wiggle pattern. Like, it's not perfect, but that has one curve. That has less curves than this, and can you kind of see how this has less curves than this because it's like flat instead of an angle. It's not perfect, but okay. We will spend a lot more time on that down the road, but I just wanted to introduce it because they're sitting right there. Velocity less than 0 means the particle is moving backwards. So backwards is either considered left or down. Some of the problems you're going left or right, but some of the problems you're going up and down. Negative, just like a coordinate plane, right? Left or down. If the velocity is greater than 0, that means the particle is moving forwards. Am I supposed to say the S there? Is it just backward or backwards? It's just backward?
Yeah, it is.
There's no S? I don't want Mr. Pena. So moving forward, which would be right or up. And then if the velocity is 0, it means the particle is motionless or stopped. What? You good? Wasn't very convincing.
We're just talking about hard backwards.
Oh, backwards. Yeah, I don't really care about that. Okay. Average velocity is not calculus. This is just the slope of the position graph between 2 points. So you could have done that in like algebra 1. It's not a thing that comes up in here a lot, but it would be like I'm here and here. What's the average velocity? You would find the slope between those 2 points. That's not really what we do here. We try to find the derivative at like 1 point, but just so you have that. And then speed. You guys know what speed is? No. What'd you say? What are you saying? Somebody say it. What'd you say? I don't even know what's happening. Can someone define speed for me? Kind of.
My state 4x1.
It is the derivative, but it's like more than that. If I said how fast were you going, would you ever tell me a negative number? So speed cannot be negative. Speed is just like the size of it. So speed is the absolute value of velocity.
Now.
So speed cannot be negative. right, speeding up or slowing down. So this is a good question to ask because you have to typically, so I can give you an equation. I can say, is it speeding up or slowing down? And the deal is if the velocity and acceleration are at the same sign, like if they're both positive or both negative, like if they're both positive, the velocity is positive and it's accelerating, that's speeding up. You're going forward and you're going forward faster. So if they're the same, the particle is speeding up. And if they're different, the particle is slowing down. So what's wrong with speeding down? How could it be speeding up but not speeding down?
Because speeding down isn't
Yeah, it's warming up. Yeah. Anyway, it's a good question for me because I can give you an original equation and ask you if the particle is speeding up or slowing down. And that would force you to take the derivative twice, find the sign of both, and then like compare them. So it's a good, remember, like you're not getting a cheat sheet or like, you're getting a cheat sheet. You're not getting a review. So if I'm sitting up here saying like, this is a good problem for you to ask, that might be something to take a note of. So this would be slowing down. This would be slowing down. Still think speeding down should be okay. Speeding up. I guess I would say slowing up. Speeding up. Because if they're the same sign, the particle is speeding up. If they're opposite signs, the particle is slowing down. Then we get into displacement versus distance. A track is a good way to think about this. So all the way around a track is what, 400 meters? Right, if you go all the way around it? Yeah, where's the 400? Is that the inside lane that's measured from? The inside 400, so it's like 410 or something.
If you were to run in the same lane the entire time, but you start farther out. So
What if you ran on the outside? Do we know that distance? Are you just like estimating them? You don't know. But don't you start on the outside and you just like get to the inside as fast as you can, right?
So, no, you start on the outside. So let's say there's lane 1. Lane 1 starts at the actual start. Lane
Oh yeah, they stagger it.
start like
Yeah.
far out.
So that must be the difference. Like wherever that last one starts, that's the distance. Yeah. Okay, so if I ran once around the track, my displacement, I started here and I ended here, my displacement would be 0. Displacement is like where are you relative to where you started. So or in swimming, I swim down and back, your displacement's 0. The distance here is 400. Like that's what I actually traveled. Displacement is like where I ended up. So 25 meter pool, I swim down and back. What's my displacement? 0. My distance is 50. Because 25 there, 25 back. So displacement is position relative to start. And distance is like the amount traveled. Yeah, but I can't use the word in the... I was about to say that. I was like, I have to think of a different word. So, I drive from here to Ann Arbor and back. My distance is probably 30 miles. My displacement is 0. I'm not sure I spelled travel. Is it 2 hours? I'm asking if it's 2 hours. Is it just one? That looks weird. Anyway. So let's look at some of the problems you would get. Displacement is the position function, basically. Displacement can be found by using the position function. So they're saying find the displacement of the particle in the first 2 minutes. They give you this equation, and what this is this particle is just, it's on the x-axis, and based on the equation, like when t is 1, it might be over here. When t is 2, it might be over here. When t is 3, it might be. It's literally just moving back and forth along this axis. And your job is to find out, okay, after 2 minutes, where is it like compared to where you start? So the displacement is found by just plugging into position. So you would go 2 to the third minus 4 times 2 squared plus 3. So 8 minus 16, so negative 8, so negative 5. We are in centimeters, so you label that negative 5 centimeters, which means you are 5 meters to the left or below where you started. Like if you're in a race, you're actually like 5 centimeters behind the starting line. Not that big, 5 centimeters like that. Average velocity of the particle during the first 2 minutes. So average velocity is just like regular old slope. So I've got 0 and I've got 2. And I'm going to find the y values of those points and then just find the slope between those points. So at 0, at the very beginning of this, whatever's happening, what's the y value? What's my position? 3, because if I plug 0 in, it'll be 0 minus 0 plus 3. And then when I plug in 2, what do I get? Negative 5, that's what I just did. And then you just find the slope between those. So it'll be like negative 5 minus 3 over 2 minus 0. So negative 8 over 2, or negative 4. And what's the label there? Centimeters per minute. So when we're in velocity, it's got to be like the distance per the time. Okay, 1 and 2. So 3, find the, can I erase them? Bleeding into the next question. Find the velocity when t equals 4. So the velocity function is the derivative of the position function. This is kind of confusing to some people because, so the position function, they might call it h for height. They might call it s, which is weirdly for position, even though it's not the first letter. They might call it x. They all mean the same thing. You just got to kind of get used to that. But the derivative would be 3t squared minus 8t. And then you would just plug 4 into that, right? So it'd be like 3 times 4 squared minus 8 times 4. So that's 48 minus 32. That would be 16. And the label on that would be I was kind of hoping someone else would chime in, but Will's got it. Still centimeters per minute because velocity is just like rate per time. All right. Find the acceleration at t equals 4. So the acceleration is v prime. I erased my v. So v was 3t squared minus 8t. So a, the acceleration is the derivative of that. So 6t minus 8. And a common question here also is not on this, but I could say like when is the acceleration equal to 0? And then you would just like set this equal to 0 and solve for t. But in this case, it's saying find the acceleration when t equals 4. So you just plug in 6 times 4 minus 8, which would be 16. Carter, what's the label there? Questions there? Yeah. You want me to slide out your thoughts? You should sit over there. You're watching my back. It'd be cool if I could like right-handed, left-handed have today. Probably good for like my body symmetry.
It helps you with things like Alzheimer's.
I've heard that, like dementia, it's good for your brain.
You can just do it on
Try it. Speeding up or slowing down at t equals 4. Someone, what? What's not changing? Okay, hold on. Before before we get into that, have we talked about the word it yet? Yeah, it. Yeah, it is a cuss word.
Yes, we did.
Oh, okay. You cannot say the word it. So add to the swear jar if you're saying the word it. Because if you say like, it's 3. Well, is that the position, the velocity, the acceleration, the x value, the y value? And it gets more confusing. Like, that is really going to matter soon. So just be very careful about like what you're saying. That it's clear what you're trying to express. Oh, you're trying to swear jar? Okay, so, yeah, anyway. No, why is it speeding up? Just velocity acceleration. So because these two have the same sign, they're both positive. Here's what I can do left hand. Speeding up. Yeah, I can't write it, but I can circle it. Or rectangle it. Alright, from a graph. So, I fear you're now more focused on my writing than the actual calculus.
Once you start writing.
So, this is a graph of the velocity. So, like we talked about this at the very beginning, but I don't know if it really sunk in or made sense. When the no, but I referred back to the. I said, yeah. Okay. So, right here is this particle moving forward or backwards? Does anybody disagree? In the window between 0 and 1, is this particle moving forward or backwards? That's a velocity. Yes. Yeah. Well, no, that's it can't be negative. If the velocity is positive, are we moving forward or backwards? Forward. If the velocity is negative, we're moving backwards. That makes sense, right?
Yeah.
Okay.
I had an A in honors physics class.
So, right here is in the 0 to 1 range, is the velocity positive or negative? Positive, because we're above the axis, right? So is the particle moving right or left, forward or backward? Moving to the right or forward, which is weird because you want to look at that and you're like, why is it going down? But that velocity is above the axis, so it is moving to the right. Why is it moving to the right? Don't say it. What? Because the velocity is positive. V of t is greater than 0.
You just said why is it? So when you say that, can we respond with it?
No, the rules don't apply to me.
Well,
It's
It's different.
That would answer the question.
Yeah, so yeah, call me on it. That's fine. Call me on
You didn't say it.
that thing. Good, okay, we can narrow it down. You shouldn't say it if you're talking about a calculus problem. Like I could say it. When is the particle moving to the left? So if it's moving to the left, what do we know about the velocity? Negative. So where is the velocity negative? It's down here. Of course, they can't make it like 1 to 5. It's like between 1 and 4.7. I don't know. Yeah, whatever. But why is because the velocity is negative. So this would be like, I want to see if we can kind of tell a story with this graph. This would be like at the start, I'm walking like 2 meters per second down the hallway. Someone just starts the clock, and then I start slowing down. Like, there used to be a principle here that I really didn't like. So I saw this person, and I started slowing down. What do I do? What am I doing right here? I'm right here. I'm stopped, aren't I? Well, what's my velocity? It's 0. Now I'm going away faster in the other direction. And then after I go faster in the other direction, I see the assistant principal over there, and I don't want to talk to them either. So I start walking. Which way am I walking right now? Forward or backwards? Still walking backwards, but I'm walking backwards slow, right? And what am I doing right here? I stopped. I turn around. Now I'm walking forward faster. And then here I'm walking forward slow. So if we're above the axis, we're moving forward. If we're below the axis, we're moving backwards. And then it goes. I'm not telling you that. You don't even know the person. This is like 20 years ago.
Is this the one that was sure that everybody on the school was gonna ask to see if they had a water bottle?
No, but this person did. Okay, they did two things. There was like, this was right around Columbine. So after the Columbine bombing, she got on the PA and said, I know the Columbine bombing was done by people in trench coats. But that doesn't mean that if you wear a trench coat, you're a bomber. So please make sure to be nice to the kids that wear trench coats. Isn't that a weird thing to say? Why would you say that? And then there was a bomb threat here, and she told, I wasn't here yet, but she told like Packard specifically, I don't know who else, will you go around in all the trash cans in the school and look for a bomb? I'm like, no, I will not.
Did Packard do it?
He did. His first year.
There's a
So it's like-
there's a difference between year one Packard and Packard.
Yeah, when you first start, you're afraid to lose your job. Like, now I have no fear. There's no fear of losing his job. So it's like, okay. Anyway, acceleration, positive, negative, zero. What does acceleration have to do with velocity? It's the derivative of it. On a graph, what is the derivative? How do we take the derivative of a graph? Take the slope of it, because the derivative and slope are the same thing. So the derivative of this graph is acceleration. So the slope of this graph is acceleration. So the slope of velocity, slope or derivative, they're the same thing. Derivative, slope of velocity is acceleration. So when is the particle acceleration positive? It's this bit right here, because the slope of the velocity graph is positive. So this is like I'm accelerating in the positive direction. So I was going backwards fast, but then I got like pulled toward the forward direction until I turned around. And I was going more and more positive velocity in that stretch. So positive is between 2 and 6, because you could say v prime of t is greater than 0, or you could say slope of v of t is greater than 0. What if you said, I'll give you a second to write it before I ask next question. So notice I said v prime or slope of. The word slope means derivative. So this is basically v prime or the derivative of v. That's what I'm writing. Could I write the slope of v prime? Remember, the word slope means derivative. So if I said the slope of v prime, I'm saying slope, which means derivative. And then I said prime, which means derivative. Now I've taken two derivatives. So be careful the way you write it. Yeah, that's the third derivative, which is true. Alright, negative. So that'd be this stretch and this stretch. So 0 to 2 and 6 to 7, because v of t slope is negative, or v prime of t is less than 0. So again, the word slope and derivative are basically interchangeable. So what I said here is velocity derivative is negative. What I said here is velocity derivative is negative. I'm just writing it. You can write it either way. Is there any spot where the acceleration is 0? 0, it's got to have like a smooth turnaround, right? In fact, could I find the acceleration at x equals 2? I could not, because I can't take the derivative at that spot. Why? Because it's a coordinate. Like, which slope would I choose, that one or that one? So you can't do it. Alright? Where's the particle speeding up? Speeding up means I want the velocity and acceleration to have the same sign. Where's the particle have the greatest speed? Sorry. So, speed is the absolute value of velocity. The first one, what? What are you talking about?
Oh!
Do you mean x equals 0? On the first one, is that what you're saying?
No,
That also,
x
yeah,
equals 0
yeah.
to x equals 2. The first line.
So it's a point. We're looking for a specific point. There's two. That and that, right? Greatest speed is basically furthest distance from the x-axis. So if I were to graph the absolute value, anything that would go below the axis, since absolute value forces things to be positive, it just bounces. And so it would look, that would be the absolute value. That would be the speed graph. It just takes everything. If it's positive, it stays positive. If it was negative, it flips up. So right here, we get a speed of 2 twice. So when does the particle have the greatest speed? At t equals 0 and t equals 2. Is that okay? So then take a second and try tunnel up. You guys do something. Easiest way to do it is probably use that speed graph I just drew. But I'd rather talk through it like to try to explain. Alright, when is the particle speeding up? In this stretch here, my velocity positive or negative? Positive, because we're above the axis. My acceleration positive or negative? Negative, because we have a negative slope, right? So they're opposites, so we're slowing down between 0 and 1. I'll justify it all at the end. I'm not going to do it every time. My next little window is between 1 and 2. Am I moving forward or backwards? Forward or backward? Backward, because the velocity is negative. Is my acceleration positive or negative? Negative. Why? The slope is negative. So we are speeding up between 1 and 2. I'm going away from my home base faster. This is like me running away from the principal. Keep going. Do the next two. Well, there's a few. Do the next segments and see what. Let's say that's 4.7. Sure. No, you're wrong. Where are those? Parker.
Parker is 6.
Oh, you went to Dylan.
Dylan feels 6.
Why you went to Dylan?
I don't know
Because when
exactly.
Dylan feels sick, it's like
Dylan sometimes he just doesn't
he
show.
wakes up and it's like,
Like he's always running to school.
I went home.
Yeah.
And once I'm awake,
Exactly. Well, Parker.
okay. I would go from 2 to 4.7, let's say. Am I going forward or backward? Backward, because we're below the axis. And my acceleration is positive. So those are opposite sides. So I'm slowing down between 2 and 4.7. In this stretch, am I going forward or backwards? Forward. Acceleration is positive. So we are speeding up from 4.7 to 6, and then slowing down from 6 to 7. If you were to look at the speed graph, so the speed again is just this graph, but you bounce off the x-axis because you can't go below it. So we said we were speeding up 1 to 2, 4.7 to 6. So it's just where the speed graph has the positives. That's another way you can look at it. But it's not always easy to make the speed graph, so you don't always have it, so you should kind of know both ways. But question on anything? Oh, it's a lot of talk. Yeah, so let me look at we'll break up the work into. Actually, no, I'm lying. There's only 9 questions. So I would expect you to have that done for Monday, and we'll be done. There's only 9. I thought it was
9 questions, and I will have 4 marks.
That's like 4 times 9.
36 questions.
36 questions on my day.
You know what it does when you tell me that's too much work?
Makes you want to make more work.
If you want
I
to-
didn't.
I was
No, I never
actually-
said it was too much work.
I'm just, he's not.
It wasn't too much.
You'll be okay. I always think we got it like 2 o'clock. You guys have 20 minutes. Like, there's more time left than we realize.
But like, once it
It
gets
looks
to,
like-
I don't want it.
Right, but that's your fault.
Well, no, but you also, if you were teaching past 2, you'd be like,
Yeah.
I ended up trying to pack
But at this moment, I realize there's 20 minutes left. I'm just going to attack that.
Yeah, that's what I'm doing.
I'm attacking it.
Is this like physics wise? Is this like, oh, no, that's all I
We did this all enough.
I meant like your college based physics.
I don't know any of this.
You haven't done that. So.
He doesn't really teach it to us.
You guys are like independent study college based physics. Have you done this stuff yet?
We kind of did this up in class. It feels very similar. I don't know.
But with the odds, like without the calculus.
Yeah, I guess I don't know. Everything's fine. I don't know if it's not exactly this.
Yeah.
It's,
Like, I think the calculus makes this stuff easier. Physics, you have like all these formulas. I don't really know where they came from. You gotta plug into one to find this, plug into the next. This is more direct.
King's Gambit.
What about the King's game?
Yeah, see, now he's.
I was watching a video on how, not how, but like I was watching.
Oh, yeah.